All right, so this is question 21.52. So this gives us the dipole moment of an ammonia molecule and the magnitude of the electric field that it is placed in. It asks us what is the change in electric potential energy when this direction changes from parallel to perpendicular. So I think the main thing you're going to need to know, well, there's a couple things, but this potential, ooh, that's not pretty, potential energy is equal to negative PE times cosine of phi, where P is the dipole moment, U is electric energy, E is the magnitude of the electric field, and phi is, of course, that angle. So when they are parallel, P and E that is, the phi equals 0, and cosine of 0 equals 1, so U is equal to negative PE. When they are perpendicular, phi is equal to 90 degrees or pi over 2, which means cosine of 90 degrees is equal to 0. So U is already 0. So U, we don't actually have to calculate that because you just have to do the first part. So let's find this U for negative PE, which they give us P and E. So it's negative 5.0 times 10 to the negative 30th times 2 times 10 to the 6th, and that will give us negative 1.0 times 10 to the negative 23rd, but it asks us what is the change, which the change in U is equal to U final minus U initial, and this is parallel is number 1, and perpendicular is number 2, so we need 0 minus negative 1.0 times 10 to the negative 23rd, so we actually end up our change in U being positive 1.0 times 10 to the negative 23rd, and this is energy, so it should be in joules, I believe. Now, for part B, it's asking what is the absolute temperature, or no, at what temperature is this translational kinetic energy, which I rewrote right here, 3/2 of K times T, equal to the change in potential energy that we just calculated, which is 1.0 times 10 to the t, or 1.0 times 10 to the negative 23rd. And we want to find where it's equal to 3/2 kt. The big thing here to remember is k is not equal to 9 times 10 to the 9th in this case. It's actually a new constant called the Boltzmann constant, which they don't mention it, but you kind of need to know that. And it's this really long number that you don't actually need to know all of that. But that's what it is if you want the whole thing. And so you basically just plug this number in right here and solve for t, and you get t is equal to 0.48. This is Boltzmann.